Histograms are an effective way to visualize the distribution of a dataset by grouping data into intervals called bins and displaying the frequency of data points in each bin. To start off, let's import our Matplotlib library .pyplot as PLT. Then we'll import our NumPy library because we're going to be needing that as well. And we're going to give our plots some style. So we'll use the plt.style. And we are going to use 538 style. Now, to create a basic histogram, we are going to need a data set. So we'll work with a simple data set where we're going to simulate a list of various ages, and we're going to see how the frequency of these different age groups appears in that list. Now, to reproduce what I am going to be creating, you could use the np.random.seed, and we're going to use the seed 36. So basically, when generating random numbers, this will make sure that everything is going to be reproduced always the same way as I'm going to be doing it right now. You could use this if you want. You could not use this, and then the random generation of numbers will be then random. But this makes sure that when generating the random numbers will always be the same in this situation. Now, to generate our list of ages, we are going to be using, again, the numpy.random method, and we're going to use specifically the randint, except we need a decimal point there. And we're going to have a range from 21 to 63, and it's going to be a size of 20 values. And we're going to automatically put this into a list as well. And when we print those ages, we get a list of various ages between 21 and 63. Now, to plot our histogram, we are going to be using the hist method, and we're going to provide the list of values, which is going to be ages. And just like any other plot, we need to add a title where we are going to call it age distribution. We're going to add an X label for the X-axis, and that's what we call ages. And of course, a Y label, which is going to be called frequency. And last but not least, to take a look at our graph, we do plt.show. And there you have it. That's our histogram. And so what we can see here is that Matplotlib automatically decided the number of bins that there should be. So in this case, there should be around 10 bins. And within each bin, it puts in the frequency or the number of ages that match within that range. Right now, this looks very smushed together and we kind of can't see these bins. So to make it a little bit more readable, let's add black edges around these bins so that we could clearly see and distinguish the bins. And to do that, we go back to our hist method and we add a edge color parameter, and we're going to give it a black color. And by doing that, when we run that, we can now clearly see that these are actually individual kind of bins rather than one big solid block. Now we could also check specifically how many bins were actually created and what are the ranges of those bins. And to do that, we will go back to our histogram method, and the histogram method actually returns a few values. One of them are counts and bin edges. And there's a third one called patches, but that doesn't really interest us. And so we're just going to use this underscore, which is going to represent that we're not going to be using it, kind of like a skipping it. And so what interests us most is the counts and bin edges. And we could print that as well. So print counts per bin, and we provide counts. And we will also print bin edges and provide bin edges. Okay, and when we run that, we can see the list, or basically the number of bins that we've created. Specifically, there are 10 values here, so that means there's 10 bins. And within each bin, what is the frequency that was added to each bin? So the first one was 2, second 4, and so on and so forth. So again, this matches this histogram. We have 2, we have 4, we have 2 zeros here. So this is exactly this. And of course, now the bin edges, which isn't really that clear when we kind of look at this. We could only kind of give an average kind of view. Here specifically, these are the value ranges between the bins. So the first bin, which has 2 values, has a bin range of between 21 and 25.1. Then the second bin has 25.1 to 29, and so on and so forth. So the values that fall between these 2 values, they get added into this bin and basically counted. So that becomes the frequency. The number of bins in a histogram can significantly affect its appearance and interpretation. Matplotlib allows you to control the bin structure in different ways. You can specify the number of bins by passing in an integer to the bins parameter. For example, we could set bins to 5, which divides the data into 5 intervals. And so we go back to our histogram method and we just set the bin parameter to 5. And when we run this, we meant bins. And when we run this, we now have 5 bins instead of 10, and the intervals for those 5 bins as well. And so this also has changed, and we have now a completely different view of this histogram. Matplotlib also has custom bins, which allow you to define the exact bin edges. And this can be useful for focusing on specific data intervals. To do that, we will need to define the bin ranges that we want to use. So let's create a custom bins list, and here we're going to define the bin ranges. So here we have this specific bin edges, but we could define it ourselves. And so let's say we want 20, 30, 40, 50, 60, and 70. And we take these custom bins and we replace the 5 here with the custom bins list. And when we run that, we now have these custom bins ranges set. So here again, we have the bin edges, and these are the bin edges that we have provided. And this as well changes the frequencies of each of the bins, which alters the look of the entire histogram as well. If data frequencies vary widely, a logarithmic scale can make the distribution clearer by reducing the impact of outliers. So let's say we have a histogram, but with thousands and thousands of values and different frequencies. What would happen is we would have thousands of values on one side, but we would have maybe just a few on a different bin on a different side. And normally when we would plot this histogram, it would be very difficult to see those very few values that are in one bin, because there are thousands of values in a different bin. So the scale is very different. And if we want to have a better view of those smaller values or less values that are in a different bin, we could change the scale to a logarithmic scale. And to do that, we just need to add the log parameter and set that to true. And when we run that again, this slightly changes it. Of course, the scale has changed as well. This might not be as visually impactful in this example, but this would definitely make it a lot more clear and when we have thousands and thousands of values, and again, if we had a very little amount in one bin. But as we could see that by changing the scale to logarithmic, this has definitely changed the look of the distribution as well. We can add various labels and additional information to our histogram charts, such as different reference lines that would indicate, for example, median or mean values, which can make the histogram more informative. So let's say, for example, we want to show what is the median age in general so that it could be kind of visualized and shown here on this histogram. So to do that, we will go back here and let's calculate the median age. And to do that, we will use NumPy median, and we'll calculate that from the ages list. Then we will create a new line, a vertical line, which will be shown on the histogram, which will be showing us where exactly is the median value for the list of ages. So to do that, we will use plt.axv line, so basically a vertical line. The value that we're going to be providing is the median age, and that is going to be basically the position on the x-axis. And we're going to make that a color equal to red. The line style is going to be dashed, and the line width, except without the quotes, is going to equal 1. Now we'll add some additional text label next to that line, and that's going to be in the position of the median age. So on the x-axis, the same position, but plus 1, so slightly shifted to the right. And it's going to be at the height of around 3. And the text is going to be median. And the color is also going to be red. And let's get rid of this log for now. Let's go back to our original chart. And when we run this, we have our dashed line here, which is the median value here, which is going to be around maybe 47. And we've labeled it with the median text. Become a member at AILearningHub.io and get access to personalized mentor guidance, early access to AI resources, help with AI projects, and a great learning community.